Welcome to the continuation, part 2 of the question 2 of paper 3. Previously, we already looked at uncertainty, measurement, roughly the same. Now, very chill one, their criteria is, the mark scheme is very chill. And every mark scheme is different. Here, you come to a question where they will ask, it is suggested that V is inversely proportional to D. Do your results support this suggestion? Explain your reasoning clearly. Oh my goodness, what is this the student writing? If you have no idea what they're talking about, don't worry. This part is also very chill one. The technique is very simple. What they just did here is they proposed a hypothesis, a suggestion. So, hypothesis. So, what's the hypothesis? V is inversely proportional to D. And they ask you, your result support this hypothesis or not? So, based on your experiment, is V inversely proportional to D? How you know? This is a very short 2-mark question. Sometimes 3, 1 or 2. Okay. So yeah, this one is a 2-mark question. But we're going to, before we mark this student's work, we are going to see what is a hypothesis and how to test it. Very easy one. Hang on with me. Let's see. Here's our pocket guide once again. Now here, whenever they propose something, they will suggest a relationship, okay? Suggest, okay? You need to see what equation they suggest. Sometimes they'll give you equation, sometimes they won't. When you see the word proportional to, okay, that means P proportional to Q, or if you want to write in the equation, P equals to some constant times Q. It's like a straight line graph, y equals to mx. Straight line graphs. Okay, that's interesting. So whenever you must first, you go and see what they propose, write the equation, like this one, and just FYI, this graph will look something like this, P against Q. You're not supposed to draw graphs, but just so you know, okay? And K is the gradient. That's what it means, proportional, P proportional to Q. Straight line graph, P, Q. No intercept. Then if they say the word inversely proportional to Q, or you see something 1 over Q, or you see P, K over Q, okay? When you see the word inversely proportional is 1 over, okay? And the equation, you must add a constant somewhere, so K times 1 over Q. K times 1 over Q. This is the equation that you will be testing. So if you draw a graph, there's 2 ways to draw this. If you draw P over Q, it will look something like this. Meow. Ayo, but we don't know how to draw curve there. We want to draw straight line. Okay. So if you draw straight line, if you plot P against 1 over Q, then it's a straight line because P equals to mx. This is a straight line graph. Y equals to mx. So, okay, now we prefer this. So it's still a straight line graph and your gradient will be K. How do you know this equation is true or not? The key lies in the gradient. See, the gradient is constant all throughout. If gradient is constant, then your hypothesis, this is the hypothesis, this is true. Because K must be really a constant K. So you check, K constant, hypothesis is true. Okay, so this is the background information of what it means, proportional, inversely proportional, and what is that K thing. K is just a constant. You can choose any alphabet you want. Alright, so we know we got an equation. What do we do next? First step, find equation. Second step, you need to calculate the difference in values. You're like, Miss, why difference? Let me rewind a bit. Let's look at, let's say, the first graph. If you choose a point here, you will get a K value. So K here will be K1, P over Q. You calculate that value. Then you choose some other point. This one, K2, will be P over Q. P2 over Q2 . Then you get some value. If your gradient is constant, then K1 should equal to K2. Because straight line, your ratio, you go down there, up there, should be the same K. Same thing for this one. If you calculate this one, you get a K1. Calculate here, what's the ratio or gradient? K2. K1 should equal to K2 for this to be true. So what we're going to do now is part 2. We're going to calculate the difference. Okay, constants should remain the same. So K1 should equal to K2, but because of errors in your experiment, your values will be a bit different, okay, due to error. So you need to calculate percentage difference. You may have seen this from other labs, but yeah, so okay. So how you calculate percentage difference? The formula is you just take absolute value, K2 minus K1 over the average value of both times 100. That's it. Okay, so sometimes it's helpful if you draw a table, you find PQK, PQK, then you find K average, what is it? And then what's the percentage difference? Show your calculation, please. So this is step 2 already. Okay, let's go and see what the student did. Did he or she calculate K? Okay, back to the student. So here they suggest what's the hypothesis? V inversely proportional to D. So when you see inversely proportional means V should be inversely proportional to D. That's the hypothesis they propose. But how you know true or not? You have to create an equation V equals to K over D. And you need to compare K. So rearrange K equals to dV. Let's see, did the student calculate? Yes, constant. So this student calculate K1 to be 14.31. K2, based on the values from the earlier section, 13.56. Wow, you see, not the same leh. This one and this one supposed to be same, but a little bit different. So how? That's when you have to use your percentage difference to see how many percent different are these two values. Okay, so let's see what the student did. First value minus second value. Okay, absolute value lah. You take the bigger minus smaller one. Divide by the average. So turns out to be 5.38% difference. That means K1, K2 different by 5.38. But how does that give us a conclusion? This is when we need to go to the last part. You got your K values, percentage difference. Now what? How to conclude? Okay, let's go back to the pocket guide again. Right, so you got percentage difference 5.38%, I think. You can write it down. 5.38 from the student. Now is when estimate of uncertainty come into play. Okay, so just now you got a lot of variables involved, right? K is, you got V, you got D, here got uncertainty. Here also got uncertainty. So what's your total experimental uncertainty? You have to estimate lor. So maybe if I earlier before I estimated 50% uncertainty, wow, maybe it's okay. Just write what you have. This is the very, very rough estimate of 50% of experimental uncertainty. Whatever value you get, just round off lah. If you get 42%, you just round off to 50. Just because it's very flexi one. CIE doesn't care what you use here. Okay, so you got 50%. Now you need to conclude. This is a suggested template of how you can explain the sentence. Oh, you must remember how to write this one. But let me explain first what's happening. So you have difference in K values. Let's say your K1 is this value. It's a number line. K2 is this value. And you say they're supposed to say more, but they are different. So how? If your experimental uncertainty is this big, okay, this green area is so big, that is an uncertainty of 50%. I estimate one lah. Then your percentage difference is, what was the one the student say just now? 5.38%. Oh, very small. So you see, the uncertainty is 50, but your difference is so small. It means they are different, but that's okay because that's included in the uncertainty. So then you say, okay, test already. Therefore, your suggested relationship is supported. Okay, I just say therefore relationship okay. And therefore you have D equals to K over V, correct. Okay, they approve. Like that. But if you have, let's say your K values are quite different lah, very big difference. Their difference is, let me give a number. Percentage difference, let's say 35% lah. You calculate to be 35. But your experimental uncertainty is a bit smaller. Whoa. Experimental uncertainty only is in this range. Uh-oh. We have a problem now. That means, let me redraw this. Let's say you have one K value. Experimental uncertainty is only 25%. You see your K value is outside your experimental uncertainty. Whoa. So here we have a problem already. K is different by 35%. That's bigger than your experimental uncertainty. So you can say K difference is beyond your experimental uncertainty. And therefore, K is different. K different means your relationship cannot approve already. Whoa. K is different and relationship not supported. Okay, kind of the reasoning lah. You say how similar are K? They should be same, but they're not same because the uncertainty cannot take that into account, so not supported. So this is a rough idea of what's happening here between the percentage uncertainties. But here is a very, very nice thing that you can memorize to use in every every question too. You just use the same thing, but you plug in your values in the blue area. So since the percentage difference in whatever constant you use is, you describe law, is it smaller or greater than your estimated percentage uncertainty, write what it is. Therefore, your experiment result support or does not support your relationship. You choose depending. So in the first case, your 50% here uncertainty is bigger than your 5%. Therefore, you can say it's support. So you fill in all these values in the blue area. Your results support the suggested relationship. In the second one, if your experimental uncertainty, 25% is smaller than your difference in K, then not support. That's just it. Okay? So how different are they and how you can use your data to see if your data supports the relationship or not. Let's see what this student write here. A bit of a mess, a bit crowded lah, but okay lah, I can read. So here this student make a conclusion on top already, kind of sketching. This student said, the percentage difference must be smaller than percentage uncertainty if not systematic at all. Okay, never mind. The conclusion is, the percentage difference is smaller than uncertainty of 130, 30%. So this student estimate the experimental uncertainty as 30%. Therefore, K is different because of uncertainty. Okay. So yeah, there's a difference, but that's okay. It's taken into account. Uncertainty is taken into account already. And the results support the suggestion. Okay, I can accept that. Let's see what the mark scheme has. Very chill on the mark scheme. First one, you check proportionality. So check proportionality is you calculate the K law. K equals to, what was the K here? dV. K dV should be a constant. So you calculate to check. Okay, so here you see they show two calculations of VD. Yep. Got show calculation or not? Got. So 1 mark here. What's the other mark come from? Conclusion. You see, they didn't talk about percentage to show or not, right? Because they are very chill. Conclusion. Sensible comment relating to the calculation and suggested relation. So it's really up to you how you want to write it, and up to the examiner how the examiner thinks you make sense. Which is why I say go memorize the sentence just now. So sensible comment. It's up to the examiner. So okay, I'm going to see. Percentage difference smaller than uncertainty, therefore makes sense. Okay lah, I accept that. So that's 2 marks. You say, miss, so many things for 2 marks. Ya lor, 2 marks. The final question is, you may ask, miss, You see the student write 30% there. Oh. Where the 30% come from? This is the experimental uncertainty. Where does this uncertainty come from? Okay, you have to estimate it again. So let's go back up to our uncertainties. Okay, there are a few ways to do this. There's a short way and there's a long way. I will tell you the short way first. Earlier, they will already ask you to estimate a percentage uncertainty for one of your variables, t. You see this one is 21%, right? So you can say your experimental uncertainty is, you just round up lah, to the nearest 10. So round up 30%. You can gauge. That's the experiment uncertainty for the whole thing, for your values. Some of you may be wondering, Miss, but then shouldn't H also have uncertainty? Shouldn't T also have uncertainty? Yes, but the uncertainty is much smaller. Oh, sorry, not H. H and D. Yeah, they have uncertainty, but the percentage is much smaller. Let me show you, for example. So maybe D, you use ruler, okay lah, plus minus 0.2 cm. What's the percentage? 13.5? No, 0.2 divided by 13.5 times 100. So this one is the uncertainty percentage of 1.5%. Aya, so small. 1.5 only. How about your height of your ruler? Let's say this one has a percentage uncertainty of 0.2 cm, which means how many percent? Times 100. 0.2 are so small. So yes, other variables that you measured got uncertainty, got 0.2 and 1.5, but they are insignificant compared to this huge one. This is so big. So you just see among all the variables, what contribute the biggest uncertainty, and you use that one, round off. You want to add, you can add. If you want to say, what if I use 21.3 plus the uncertainty 0.2 plus, add together, you say, Miss, my paper 2, I can add uncertainty. Can. You do that. Plus 1.2. How much you get? 21.3 plus 0.2 plus 1.2. Not much difference. 22.7. So small. Might as well just round off, save your time, because it's only a 2-mark question. So, moral of the story, when you are using your hypothesis you're checking your hypothesis and you want a conclusion, just take your uncertainty answer, round up to the nearest 10. So 10, 20, 30, 40, 50. Okay, that's it. Very easy one. Okay, so that's all for this part on testing hypothesis. Now there's one more student's answer down here. Let's take a look at it before we call it a day and go to the last video. This one already marked. So this student, let's see. First, you need to show calculation. You need to show proof of calculation. So let's see. Got show proof of calculation or not? Okay, got one K value here. This one, not very sure where is the other K value calculation. I'm not sure what this student is calculating, so I'm a bit confused. I know 161.5 is K1, so let's label that K1. Then where is K2? You check and see, 164.118. I guess it is one of these. This one, maybe. Okay. So the professor just say and then compare this one equals to this one or more than this one. Therefore, no, it doesn't. This one is maybe at most I will give 1 mark only. Because, yes, the person calculate K, but the conclusion is not really, it doesn't make sense. This K1 is greater than K2, therefore it doesn't support. You need to explain why. That's where the percentage difference come in. So I want you to talk about percentage. So this one, not very specific. You want to talk about velocity. You want to talk about percentage difference and things like that. The reason why you lose the mark is, yes, K1 is bigger than K2, but is the difference because of uncertainty, or are they really, really different? That's where the percentage thingy have to come into play. See? So I write, is the percentage different because of uncertainty, or really, really memang different? We don't know. So I'm not very convinced. So if I'm a very strict examiner, I will say, no, you won't get the other mark. But if I'm a very lenient examiner, I might give you the mark that you're missing. So best bet, you give the examiner no chance to deduct any mark. You write the whole sentence out. Percentage difference, experimental uncertainty, reasoning, poof, get your 2 marks. That's all. So 2 marks only now. So like this one okay, I can accept. So that's all for this part on hypothesis. Just remember, first step, what is the equation that they are suggesting? What is the constant? Calculate your constant. Is the constant the same? Find the difference. Then you write your sentence already. Over time, you will get better at doing this. Maybe the first time you're like, oh miss, I can't remember how to do. It's okay. Just grab a piece of paper, write down how to do this, or you look at the pocket guide, how to do this, refer to, and then practice over time. You will get this one real quick. Okay, so up next will be the last part that has a lot of marks, probably the most. And that will be in part 3 of the video. So I'll see you there.